Alright, hello and welcome. This tutorial is based on a comment from one of my subscribers, Blummy the Boy. He wanted me to try to recreate the gameplay style of the game Control. So, this is my best attempt at that. If you want to do this, follow along. It'll just be 1 hour. Alright, so first off, let's go ahead and find this neutral stand idle animation and duplicate it. This is the base idle animation they use, and so we're going to go ahead and edit this. So after we duplicate it, let's go find the clavicle and the upper arm and the lower arm. Those are the bones that I'm working with right now. I just want to make it look like he's kind of doing a telekinesis grab thing where he's just like, you know, grabbing at the air. And so I'm just editing these bones to get in the location that I like, and then once I got them in the right place, I'm going to hit S to key all the bones that I moved. I only need to hit S once and we'll do all three, just like that. If you don't want to hit S, use the arrows next to the skeleton and hit set key. Alright, so now let's go into the Sandbox character, what we're going to be doing this, and then go into his animation blueprint. I basically only want to play this animation when I'm aiming. And the Sandbox character comes with an aiming function, so we're just going to go in the ABB and grab the sandbox reference that's already in there, and we'll, from wants to aim, promote that to a variable. Alright, so now this is a variable inside of the animation blueprint, and its value will be the same as the sandbox character's value. So when he's aiming, this will be aiming in the ABP. Alright, so in front of the default slot, let's go ahead and drag in this TK animation that we just created and make sure it's set to looping on the right in the details. And we're going to go ahead and cache everything before the default slot. So off of that, let's go ahead and type in cache, and we can name it something like before telekinesis cache. Alright, and then we want to grab the cache that we just created, so search for that. And then once we have that, we will go ahead and blend pose by bool. We're only going to use this TK idle loop when we're not aiming. So from wants to aim, we want to get a not and then attach that to the active value. So when we're not aiming, we're going to be using our normal cache, and then when we are aiming, we're going to use this telekinesis one. All right, so we want to get a layered blend per bone, and we want to use the same cache and combine that with the loop and then connect that to the false pose. All right, I'm going to change these blend times to something like half a second. It'll be a little bit cleaner. In the layer blend per bone, under the layer setup where branch filters are at, we just want to add one and then have it be the clavicle R. Alright, so everything after the clavicle will use this pose. Alright, and you can see if we check it just by default, but we're not going to do it here. I just wanted to show you. And it's right click. The default on the aim for in the sandbox character is the right mouse button. Okay, so now let's create a material that will highlight the thing that we're looking at with the camera, the thing that we want to pick up, the object, the telekinesis object. Okay, so create a material and then click on that material and then change the material domain to post-process, because we're going to add this material with a post-process volume. We will add that later. All right, so hit S and then click. That will create a line, that will create a parameter. You can also right click and search for scalar parameter. Right, and I'm going to make the default value 0.3. And then for multiply, you can press M on your keyboard and then click, and it will create a multiply node, or you can just search for multiply. All right, and now we're going to look for the view size, and we're going to look for a seal, which is short for ceiling. We will go through this after we do all this. I will kind of go by node for now, but for now we'll just go ahead and get the nodes out here, and then we can go over it later. All right, so we're going to look for a clamp, the min 1, the max 2, and then plug that into the B of the multiply, and then we want to make another multiply node and attach the previous multiply to that A, and then we want to get a scene texel size and then plug that into the B of the multiply. The scene texel is useful for edge detection, right? So we want to highlight the edges, so that is useful to us. All right, so now we want to get a component mask. And for us, this is going to be XY. Even though it says RG, we are dealing with XY. All right, so if we just only want to check R for the top one, And then for the second one, we only want to check G. So for the top one will be X, the bottom one will be Y. And now we want to, off of the top one, grab an append, and then duplicate that, and then plug that into the B of the bottom append, the bottom mask into the B of the bottom append. And now we want to get another scalar parameter. So hold S on your keypad and then click, and that'll create a scalar parameter, search it. And we just want to attach that to the B and the A of the corresponding append nodes. All right, and we want to create another parameter and put that right after that. And we want to get another multiply node and connect the append node into the multiply node. And we'll get the another append node, the bottom one, and plug that into a multiply, into the B. And then plug this parameter into the corresponding nodes that are empty on the multiply nodes. All right, so now we want to get a screen position. And we want to use the viewport, the UV of the viewport, what we're currently looking at. And we want to get another component mask that's using just the R and G. We're going to keep those checked, but instead of R and G, it's X and Y. Just think about that like that. We'll get 4 adds, and we're going to plug this into the top of each of those adds. Like so. And now from this multiply, we're going to plug the append into the bottom, and then of the top add, and then the multiply into the B of the second add. And then the second append, we're going to plug into the B of the third add, and then the multiply will go into the B of the fourth add. And then you can clean it up like this. So go ahead and pause the video and arrange it like so if you need to. Okay, so move the post-process material out a little further so we have some more room. Now we want to get some scene textures. And then in the scene texture ID, we're going to go ahead and change that to custom depth, because we're going to be adding a custom depth inside the post-process later. All right, so we want 4 of those, 1 for each side of the outline, and then a top one that will be subtracting all of these values. All right, so we want to plug the adds into the corresponding scene texture custom depth node. Death node. It's the sequel to Death Note. Anyways, no. All right, so we get 4 subtracts, and we're going to plug the color into the A of each subtract, the top color, and we're going to plug that into all of those subtracts. And then we're going to subtract the corresponding custom depth node. And essentially what's happening is the top custom depth is everything in the scene, and it's subtracting these values one by one. And then we're going to add them all together to get an outline. And it will make sense when I go over it. It'll be a little bit more clear when we can see what's happening when we disconnect these. We can see what they do. All right, so attach these like so. The subtract is going in to the B. And we get add, and we add those all back together to get our final outline. All right, now we want to divide this by another scalar parameter. So off the add, search for a divide. And now search for scalar parameter, or hold S on the keyboard and then click to bring it up. And this will be edge angle fall off. Plug that into the B and set a default value of -100. And then when we get into the material and we actually apply it to the things, you'll see what these scalar parameters kind of change. So from that divide, get us another subtract node. And from that subtract node, we want to get a clamp. And now we want to search for another scene texture. But this time we're going to make it a post-process input. And that color is going to go to the A of a lerp. We want to search for a lerp. And then hit 3, hold down 3 and click and that'll create a color. Otherwise, you can search for color. Right click on the color. We want to convert this to a parameter. And then make float 4. And this is going to combine all of these into one result so that it can be plugged into the lerp without creating an error. So click that result into the top A and then plug that multiply into the B of the lerp. And then we want to get another scalar parameter. And then we'll name this outline glow intensity. Give it a default value of about 0.5. And then from that, plug that into the multiply. And then that clamp is going to go into the alpha. Just like so. And then everything goes into the emissive color. And compile and save. So this parameter here needs to be -1. This parameter 2, I never added a value. The default value should be -1. So this view size is outputting a 2D vector, an x, y. All right, the ceiling is a brother-sister node of the floor node. A ceiling will take an integer value and it will round it up to the next integer. So if you're dealing with like 1.5, the ceiling will move it up to 2. If it's 1.1, the ceiling will move it up to 2. If it's 1.01, the ceiling will move it up to 2. The floor will bring it down the other way. So this view size is your screen resolution. Mine is 1920 by 1080. And so the ceiling, is gonna put it up to 1080 or 1920, and the clamp is 1 to 2. So you could put a scalar parameter and put the default value to 2, and then run that into the multiply instead of having that clamp, and you're basically going to get the same result. All right, the scene textual size, that's for looking for edges. All right, so this view size is dealing with X and Y. So this mask is R and the G. The R is X and the G is Y. All right, and the append is allows you to add another channel to something. So what a channel is, like if you look at your normal basic texture sample, R is a channel, G is a channel, B is a channel, RGB is a combination of those channels together. All right, so what the append is doing is it's taking the mask R, which is an X, and then you're appending something to it. So now it's X, Y, it's another channel. So, and then if you're dealing with RG, which is XY, and you append that, that's going to add a Z value essentially. So I know it's saying R and G, but you got to think of it, since we're dealing with the view screen, which is an X and Y, these are X, Y, Z. So B is Z. If you're going to append a mask that is X, Y, that's essentially adding a Z value onto it, if that makes sense. This is a crash course on materials. Hopefully it'll get you a little bit more interested in it. So we want to add a post-process volume to this scene. So go to place actors and search for post-process volume and drag it into the scene, and then make it unbound. Search for bound and then click unbound. And now we want to go to our material that we created just now. We want to right click that and create a material instance. It will make it much easier to edit. And then we want to search for material inside the post-process volume, and then where it has array, we want to add an array element, and we want to add the material instance that we just created that we're putting in. All right, because when we're using material instances, it makes it much easier to edit materials on the fly. You can kind of see what these are doing now. See, these parameter and parameter 2 are creating some type of like boundary or bounds that the highlight can go towards. All right, so just go ahead and play with these values and get something that you like. See, this edge fall off kind of adds more edges a little bit, you see, which is could be pretty cool. So you can play with that, you know, and the color obviously messes with the color. Okay. So now that we have this highlight on there, let's go ahead and take a look at this inside of the material. Like what happens if we uncheck one of these, right? What if we don't subtract anything on that bottom value? What happens? Okay, it gets rid of that side. And what happens if we get rid of this? Okay, it gets rid of that side. So as far as I understand, what's happening here is you have the scene texture custom depth, which is the top one, which is the whole scene. And then you have the 4 below it, which is each perspective side, or each respective side. So the bottom, when we uncheck that, the top was no longer there. So from what I understand is happening is you have the full scene, and the bottom one is subtracting everything but that line. And then it's being added after that subtraction. After the subtraction, you're left with that line, and then you add it back to all the other lines, and it creates the outline. So when we uncheck it, it's not there, right? So if you unhook this in the beginning, it's completely filled in because nothing's being subtracted. In the video that I got this code from, in the comments, someone suggested to go into the post-process material settings and change it to scene color before balloon rather than after tone mapping. And you can see if you do it after tone mapping, it kind of is like very wobbly and jittery. And if you change it to scene color before bloom under post-process material, you can see it's not quite as jittery. It's way more thin, but we can go into our material instance and we can increase the line width to something like 1, you know, and it won't, it's still jittery, but not quite as jittery. Okay, so now we want to get into our Sandbox Characters event tick inside the event graph, and we want to check for get wants to aim. We want to see if we're aiming, because if we're aiming, we're gonna do a trace. So from that aim, we want to get a branch, and we want to do a line trace by channel. And from the true, if we're aiming, let's trace. All right, and we're going to use the player camera manager. So get player camera manager, and from the return value, we want to get the camera location, because we want to get where our camera is at and where it's looking at, because we're going to trace based on that. So from that return value, plug it into the start, and now we want to get actor forward vector, you know, where the camera's looking at, where, you know, where it's facing. And then from the return value of the camera location, we want to drag off and add. And then from the get actor forward vector, we want to drag off of that and multiply. And change the multiply, right click that bottom pin and change it to a float. And we want to plug that return value into the bottom of the addition of the camera location and plug that into the end. And that times 1000, that's the distance that we want to trace for. All right, so let's go ahead and test if this is working. From the return value, let's go ahead and create a branch. And then from the true value, we'll just print a string. They'll say hi to us when we're close enough. All right, so that's a little too close for me. I would like to be a little bit further, so I'm going to change that to 2000. And the draw debug type I changed to 4:1 frame. So I didn't mention that before, but that's so you can see where you're tracing it. And once it's working how you like it, you can change it back to done. Okay, so from out hit, we want to search for break hit result, and then from that hit result, we want to grab the hit actor and check if it's valid. Right, because we only want to do this if the thing we're hitting is valid. And we want to check if that actor has a tag, because we're only going to grab objects that have this tag on it. All right, so from that return value, get a branch, and from the is valid, plug into that branch. And now from this hit actor, we want to get a component by class. We're going to be dealing with static meshes. So we want to see if the actor that we're hitting has a static mesh component attached to it. All right, so we're going to check if that's valid, because we only want to go forward if the actor we're dealing with has a static mesh component. All right, before I do the rest of the code, I want to explain what I'm trying to achieve here. We're using this trace to highlight a static mesh that our camera is looking at. All right, so we want to store that static mesh. If we're looking at it, we're going to create a variable for that static mesh as our current object that is being looked at. All right, and then say we move to a different object, right, and that can be picked up. When we hover over that, now we want to check if it's a different static mesh, and if it is, we will unhighlight the original static mesh, and then we will set the new static mesh to our current telekinesis static mesh, and then we will highlight that one. And from that return value, let's promote that to a variable and call it a current TK, because we want to store the current object that we're currently tracing to. All right, and then we're going to check if that's equal. You can delete that once you've got a variable of it. Now we want to get the variable, and we want to check if it's equal to the static mesh that we're currently tracing. All right. So this is like if we'd already traced one before, and now we're tracing a second object. So that's what's happening now. And now we're checking if that second object is the same. All right, so we want to convert this TK to a validated get, because it will create some errors. If this doesn't exist, it will create an error. So we want to get a validated get of our current TK, because if they're not equal, if the static mesh that we're currently hovering over is not equal to the one that we hovered to previously, we want to unhighlight the stored object. All right, and then we want to set the stored object to this new static mesh that we're now highlighting. All right, and then we want to highlight that new static mesh. So look for set render custom depth and set that to true. All right, so if it's not equal and we haven't hovered over an object before, we're going to set that to our current telekinesis object that we're highlighting. All right, so that's what we're doing there. And also on the validated get of the TK object, when it's not valid, we want to run that into set TK object as well, because when we very first start, our TK object is going to be just a base static mesh that won't be equal to the one that we're trying to check if it's equal to, and it won't be valid. And so we need to override that and run it into the set TK object. So now we want to undo this if we're not aiming. So copy the validated get and the custom depth node and paste that down to where we're aiming. And if we're not aiming, then we will unhighlight our current telekinesis object. All right, and then let's go ahead and grab this tag TK underscore target. Let's go ahead and add that to some blocks that we have inside of the map level. So go to event, search for tag, and go to actor and add a tag, and then paste in that tag name TK underscore target. Now let's test it out. All right. See, so that's what we were trying to do. Okay, so now let's create a new variable, and we'll call it TK object selected. So this is like if it's highlighted. You could also name it TK object highlighted. Right, but this is the current, hasn't been grabbed yet, it's just selected. Right, so at the end of that trace, we'll set it to true, and then when we're not aiming, we will set it to false to unhighlight it. Okay. So now we want to create an input to grab it. So right click, jump, and duplicate that. We're duplicating jump because it's a digital Boolean and not an access. Rename it something like IA underscore TK. Now let's open up the IMC_GDC and then add a mapping, hit that plus, and then add IA_TK. Now I click on the keyboard and choose a button. I'm going to use the left mouse button, and then I'm also going to add a gamepad button. I'm going to use the trigger. It's just good practice to always have a corresponding gamepad input to your keyboard inputs. All right, so let's open up our UEFN skeleton, and under animation where it says preview, let's change that to use specific animation and find the looping TK animation we created earlier. All right, so we want to add a socket to this. So I'm going to add it to the root. That way it's not really moving. Like if I put it on like the clavicle, for example, name it something like TK_target rest. If I put it on the clavicle, when the character starts running forward and he kind of like bends over, you could get this thing where it starts going into the ground, the object that you're working with. So that's why I chose the root. So right click on that target on the socket, and you can go down to preview asset and add a preview asset, and then move the socket until you have it floating where you would like it to go. All right, and then delete the asset. All right, so back inside of the sandbox character, let's call that input we just created, IA_TK. And let's create a new variable, and I'm going to name it, it'll be a Boolean. I'm going to name it TK object grabbed. So this will be when we've actually grabbed the object and now it's floating near us. Okay, so let's get that variable and get a knot and attach that, and then attach that to a branch. So if the object is not grabbed, then we will go forward with this code. All right. You can also check if it's selected, but it should only be able to be grabbed if it's selected. So this might be redundant. All right, and we're only going before we're tracing, we don't want to trace if we have an object grabbed already. It will create a bunch of issues. So we only want to trace for that object if we don't have something grabbed. If we have something grabbed, we want to not highlight new objects until we've thrown our object. Okay. All right, so go back to our IA_TK, and if our object is selected and grabbed and not grabbed, then we will set it to grabbed. All right, and now we will grab our current TK, and we will, we want to remove any physics on it. If for whatever reason it has simulate physics on it, we don't want that to be happening when it's floating near us. And then from that simulate physics, we want to set timer by event and change the time to something fast like 0.01, and click looping and max once per frame to true. The max once per frame might override the time of 0.01, but that's okay. All right, so we can name this custom event something like grab TK object _ custom event. You're going to right click and add a custom event. You know, that's how you add a custom event. And then from that, we'll get a branch. And let's drag our mesh into the event graph. And we want to get the socket location. We want to get the socket location that we just created off of that root bone. And now we want to get our current object that we have currently grabbed. We want to get that world location. Okay, let's go ahead and copy this socket name and paste it into the socket location name. And then we want to check if these locations are equal within a within one, you know. And then if they are equal, then we want to clear the timer. We don't want this timer to be going anymore, because this timer is going to allow us to move the TK object to our hand. Right? It's going to do that, we're going to use something called a vinterp2. Right? So we're going to move the current location of our TK object. We want to move it to the location of our socket, of our hand. All right, and our delta time will be get world delta seconds. Search for that. And our interp speed, I'm going to put 5. All right, and we want to set the current TK object's location to this vinterp return value, right? Which over time will be where our socket location is, floating near our hand. Okay. So we want to check if this is currently grabbed, because we can throw it. You know, it might not be in our hand at this point, right? So that's why we're doing this. It's to check if for whatever reason it's no longer in a hand. Maybe we're not aiming anymore and we just dropped it. Okay, so that's why we need to check if it's true here. So only if our object is grabbed are we going to continue to move this, interpret this to our socket's location, right? If it's not true, we're going to clear the timer and we're going to clear and invalidate the timer, okay? But if it's true, we're just going to set that world location over time. All right, but if once it reaches its location, then we are going to attach component to a component. We're going to attach the current TK, which is our target, to our mesh. We're going to attach it to that socket name, TK underscore target rest. And then the location rule, we're going to have it keep to the world, so that stays kind of where it's at, the rotation and everything like that. Okay. And since we added these new variables, we want to add those at the end of when we stop aiming, we want those to be false as well when we stop aiming, right? So we need to add those if we're not aiming anymore off of the IA aim input. And then get our current TK object, and we want to attach that essentially to nothing. So attach component to component and leave the parent empty and keep world. And then we're going to, from that, we're going to simulate physics. So it just drops to the ground. And that's one of the reasons why in the code we just did before this, why we made sure that the physics was not being simulated, because we do simulate physics for it to fall back onto the ground. All right, so let's test out, see what we have here. Okay. All right, so when we're dropping it, something to keep in mind is these objects, this pivot point is not in the center like on the white block. The white block has a center pivot. These blocks don't. It could create an issue where, you know, say you're stacking blocks and one falls over. Now the pivot point is going to be above, and so when you grab it, it's going to not go as high as where it should. So that's something you want to keep in mind when you're dealing with objects. Try to use objects that have a central pivot point. Okay, so off this, I'm going to collapse this trace function off of the event tick. I'm going to collapse it all to a function. Just name it something like trace for TK object. That was the code that we had off of the event tick. All right, and then same for this code that's coming off of stop aiming. I'm going to grab all that. I'm going to collapse that to a function as well, just to clean up the graph a little bit. And then I'll name this release TK object. Okay. So I want to create a custom event that clears this timer, because we're going to throw this object, and once it's being thrown, we don't want any, it's not going to be grabbed anymore when it's thrown. So it might try to interpret it to this hand location. So rather than do that, we're just going to clear it. So I want to create a custom event that's going to go right into that clear and validate. Because TK object, if we hit the left button again or the input again, once we have a thing grabbed, we'll throw it. All right, so we'll grab those two, grab the function, the release TK object that we just created that came off the end aiming, and then grab the clear timer CE custom event we just created that clears the timer. And now we want to create a timeline, and we can open that up and change the track time to like 0.3 seconds. And that's like how long this throw will be. All right, so, and we want to have that to play from the start, not play from the beginning. We have it play from start because we can drop it and then pick it up again, right? And then if we had it at play, it would be some crazy things. We wouldn't be able to throw it again, essentially. So if we play from start, we can drop it and pick it up and throw it again. All right, so from the current TK, we want to add force and then plug that into the update of our time. And let's go ahead and go into our trace for TK object, and let's copy some of this code. We can just reuse some of this. Delete the trace. We just want the direction, essentially, because that's the direction we're throwing in, the direction that we're looking at, essentially. All right, and this is like the force, because when we click Excel change, it no longer factors in mass, and it's just kind of the force that you're throwing it at. Okay, so this is kind of the effect that we get when we do that. You can still grab it while it's in the air, which is, kind of cool. I don't know if you want it to be able to do that or not, but you could kind of do a thing where you check if it's in the air, if it's being thrown, and then. But anyways, I'm not going to do that. So inside of this release object TK, we want to remove this TK object grabbed, and I'll show you why. We want to put that after it's finished. We want it to still be quote unquote grabbed until it's finished, because, and then we'll just put that at the end of this after that function. Since it's not in there anymore, we got to put it at the end of it. And we're doing this because this is on the event tick where it's checking if it's grabbed, and if it's not grabbed, we'll start line tracing for new things. So if you threw it, and then it runs that function where it unchecked it being grabbed, it will start like tracing again and doing all this weird stuff. So remove that from that function. Something to keep in mind about timelines is they work off of the frame rate that you're working with. So if your frame rate is bogged down, you can have varying results based on your frame rate. So that's something to keep in mind when using timelines. You could use a physics thruster if you'd rather use a physics thruster. I did not do that in this video, but you can try that route, and that's not dependent on frame rate. So let's go ahead and create our own objects. Let's go into modeling mode and go to create and create a box. And I'm just going to change everything down to like 25 units, width, depth, height. And because we're gonna break these suckers. We're gonna crumble them. All right, so we have this box, and then we can change. We go to X form, and we can change the pivot point, edit pivot, and then click on center. We're under box positions. Okay, and that's gonna change it to the center, so we don't have that weird issue where if it's like falling down, the pivot point's gonna change, and so it's gonna go to a different position when it's floating in our hand. Well, that will remove that. All right, so let's open up this box that we just created. We can name it something like cube. I would name it cube underscore static mesh. It's not a geometry collection yet. Okay, and then make sure it defaults to complex collision. We want to change it to simple or project default, and then re-add the box simplified collision. It wasn't allowing me to throw it when it was on complex collision. All right, so then now let's go into fracture mode and click on new. When we have our box selected, click on new, and then we can change it to box underscore GC for geometry collection. Let's move this out a little bit more so we can see. And then we want to select all. Make sure you select all, click that, select all, and then you can click on uniform or cluster or whatever, and then you hit fracture. And this gives you a preview. But once you're ready, hit fracture and it'll fracture it. And then we can go back to selection. And I'm going to create a blueprint for this. I'm going to have it be an actor. And I'm going to name it TK underscore object BP. And then I'm going to add a static mesh, because that's what we're looking for in our trace. So we need to have a static mesh, but we don't need to add anything to it. We don't need to put a static mesh in here, because this will just kind of be a default object where we can add things to later. And so we want to add a sphere collision, because based on the sphere collision, when it collides with something, we'll break the object. Okay, so drag that into our map. And under static mesh, we can add the cube that we created. Mine is named GC cube. All right, and then you can pull it up, and if you hit the N key, it will snap it to the ground when it's floating above the ground. All right, so on this, we want to search for tag, and we want to, in the details, we want to add that tag from our trace for object TK. We want to grab that actor tag that we're looking for, and we want to make sure that this has that tag in there by default. So hit the self, and then under details, search for tag and add it there. And now inside of the TK object event graph, when the event begin play starts, we don't want that sphere to have a collision off the get-go because it would just crumble essentially right when we walk into its range. So we only want that collision to be enabled once we throw it. All right, once it's being thrown. All right. So until then, we'll have it be at no collision. So on our sphere, let's right-click that and choose on component begin overlap. And then for the other, we'll drag out and we will cast to a static mesh component. And then we're going to check if it's equal to ourself. We're going to check if it's equal to the static mesh. So drag our static mesh from this and set it, check if it's equal. Because if it's equal, we don't want it to crumble, right? We don't want it to, collide with itself and then crumble. So we added that in there. And so now let's create a folder for our TK objects. We can move that in there. I want to create a blueprint for our geometry collection, the thing that's going to crumble. So I'm going to duplicate this and name it _block or TK _ object BK, or no, TK _ block BP. Block GC for geometry collection. Sure. All right, so we don't need any of this in there. We don't need the static mesh. We don't need the sphere. We just want a geometry collection. And we're just going to have it be the GC box that we created. Because we're going to spawn this essentially when that other thing, when our original TK object hits something, we're going to spawn this at that same location and have it crack. Okay. So if our static mesh is not equal to the static mesh that we're overlapping with, then we will get the world transform of our static mesh, and we will spawn an actor from class and have it be the GC block. And the spawn transform will be the transform of our static mesh, its current rotation, location. All right, and we'll get the static mesh again, and then we will destroy that component because now the block is there in its space. All right, delete that. That was from a test. We don't want that code. Okay. Instead, we're going to spawn actor from class. We're going to spawn a master field, and we're doing it after the static mesh is destroyed. So the class is master field, and we want to get the transform of the block that was spawned, and we'll spawn the master field right over that block, because the master field is gonna break the block. That's what the master field does based on its activation type. So its activation type is delay, so that means after a certain amount of delay it's going to initialize the field, and this field is designed to break things. Okay, if you want to look into it, I'm going to change the delay amount to 0.05 inside of the master field. I suggest duplicating the master field first and then adding it to your content folder rather than doing base changes to the master field. But in this tutorial, I'm just going to edit the master field. I changed the delay to 0.05. That means after 0.05 seconds, it's going to crumble that block. All right, so inside of our sandbox character, before we throw our TK object, we want to cast to that. So we want to get our current TK, we want to get the owner, which is the owner of the static mesh, and then we want to get the sphere from that, and we want to add its collision. All right, so now it can be broken. Now it can overlap things, and if it can overlap things, then it can spawn that master field, which can break it. All right, and then we want to just put that right in front of there, right in front of the timeline. Well, I have it. Okay, so it's giving us an error. Add force because the current TK was destroyed before the end of that, before the timeline finished, which is fine, you know. So we just want to make sure we convert that to a validated get, so it doesn't try to add a force if it's been destroyed already. Okay, so that will get rid of that error. So let's just create a little bit of flavor. Let's have our fist close when we grab the object. So we can duplicate that TK loop that we created earlier, and we can rename it to like TK grab or TK object held. Okay, and then it's gonna be really simple. We'll just go and edit the hand to be a fist. So we just go into our right hand, our skeleton tree, and go find our right clavicle, and then lower our index fingers will be, our fingers will be below there. Okay, so just make the best fist you can. And then when you're done doing that, just select one of the bones that you moved and then hit S to key all those bones at once. And then it's crazy how much flavor just adding a simple animation like this adds. We'll add a throwing animation for when we throw the object. You can also use control rigs if it has a fist, but my control doesn't have a fist one. Just edit at the thumb a little bit, fix the pinky, and then hit S, and that'll key all of them. Select the. You got to make sure you're selecting a bone that you edited though. Like if you select a random bone, and hit S, I don't know that it will key everything. You want to select one that you moved and then hit S. All right, so this throw animation that I added in the link, you can right click that and create a montage with that. We'll go back into our sandbox character, and on the throwing, before we throw, but after we've casted and added collision, let's go ahead and play an anim montage. And go ahead and connect those nodes, and then let's go ahead and use the throwing montage that we just created. And then connect that to the release TK object. And compile and save. Okay, so now we need to go into our animation blueprint and add the closed fist animation that we created. And so let's drag that into our anim graph where we did the blend of our normal TK loop. Let's go ahead. We're going to want to copy that blend posed by bool. And if we have an object grabbed, then we want to have a closed fist. Okay, so that's our TK object grabbed. So from our sandbox character reference back in the event graph of the APB, where we got our aiming, we want to get TK object grabbed as well. We want to also promote this to a variable. Okay, so if it's grabbed, we will have the grabbed animation. And if it's not, we will have the normal idle open hand animation. Now you could change the time blend on this because it's a little bit, you can close the fist a little bit easier. Okay, and just plug that into the blend pose of that layered blend per bone that's coupled with that cache. All right, and you can see here. Close. It just adds a lot just being able to do that. Okay, what if we wanted to have a different kind of object? Then let's do that. let's create. I'm just selected a torus. You choose whatever one you like. And just go ahead and mess with the scale until you get something you like. And once you got something you like, hit accept. Hey, I like that. All right, accept. And now we want to go ahead and open that static mesh where it's at in their folder and rename that to torus underscore static mesh. And remember, we got to go into the static mesh and make sure it is not complex collision. So I'm going to put it to project default, and then I'm going to just add a box collision to this and just quickly. Now you can use auto convex collision. I don't do that a lot of the time because I feel like it creates holes in the static meshes. If the more complex the convex static mesh is, the more likeliness there will be holes. Like if you're using that, like, and what I mean like holes is you're walking on the static mesh and you just fall into it because the convex collision didn't really encompass everything like it looked like it did. Anyways, this isn't necessarily the best. I prefer to use box collision when I can. These could be a little bit smaller, so there's a little bit less edge, but for now, it's good for me. All right. Now let's fracture this. We want to make sure, well, we have to click new first, create a geometry collection, find a folder and create geometry collection. Make sure we have select all, and then fracture. Okay, click fracture. Okay, and once you hit click fracture, save. And we can go back into selection mode. And let's create a enumeration. Right click, go to blueprint, and create enumeration, tk underscore object, or e underscore tk underscore objects. And create two, just one for a block and one for a torus. I hope that's how you say torus. You could say donut, like Ramsey. Anyways, okay, so let's move this out a little bit. This is inside of our TK object blueprint. Right before we spawn our block, we want to create a variable, and we want it to be the enumeration we just created, e underscore TK objects. And we can name the variable something like TK objects. And then we want to switch on enumeration, switch on ETK objects. Right? So if it's a block, we'll spawn a block. And if it's a torus, we'll spawn a torus. So let's go ahead and copy and paste that. Connect that to the torus. And connect the return value of the static mesh transform to that as well. Let's go ahead and duplicate our block GC and name it the torus GC. And we'll open it up. And instead of the block geometry collection, we'll use the torus geometry collection. Okay. And because we created these, go into the details and we can check remove on sleep. Do that for the block. If you didn't do that for the block, that means after that time that was given on that, the blocks, the crumbles will slowly disappear. All right, so on this, we want to choose the torus instead of the block. And then we want to copy and paste this down here. So because we used we created it first in the modeling mode, and then we used that same static mesh to create the geometry collection, we can use the transform. So like if you scale it up inside of your map and spawn it using the transform of your static mesh, the geometry collection is going to have that same size because you created the geometry collection from that static mesh. All right, so just and recreate all that code. And then let's create a test dummy. So right click blueprint and create an character. And we're using a character because characters can be launched. I'm going to use the UEFN mannequin, and then for the blueprint, first off, let's create a new physics asset for this UEFN. So physics asset, create and assign. And we're doing this because the default one that came in the GASP project doesn't fall when you simulate. So that's why I'm creating a new physics asset. I'm going to give it the same animation blueprint as the Sandbox character, just for now. Just so you know, that wouldn't work if you actually start moving the character, because the Sandbox APB looks for specific references from the APB blueprint. All right, but the idle and stuff will work. Anyways, for our purposes, it will work. And then we want to make sure we search for our physics asset. We search for our physics asset, and then we want to apply that physics asset as an override. Okay, and once you have that, go down to our collision presets and change it to ragdoll. And then our location is -88 on the Z and -90 on the Z. Okay. Inside of the TK object BP, off of the on begin overlap of the sphere, create a sequence node and run the code that we created originally. Run that from the then 0, and then we'll do the rest of this code that we're going to create now from the then 1. So inside of the TK object blueprint, where we're doing the overlap sphere, from the other actor, let's cast to character. And from that, let's see if it's equal to our player character, because if so, we don't want to do anything. We don't want to launch our character if the block hits us. So from that return value, we'll get a branch. And if it's true, we'll do nothing. But if it's false, we will set simulate physics on the mesh of the character. We'll set that to true. And then we will get actor forward vector. This is the TK objects forward vector, the block that's being thrown, or the torus, and we want to from that get vector length XY, which is kind of like a speed. You can use that for speed in the animation blueprint. From the as character, we will launch character. So we are launching the character that this block is hitting, and we will plug the vector length XY into that launch velocity. All right, and then from there, we will, from the character, we want to get capsule component, and we want to set that to, we want to set collision enabled to no collision. That way, so what happens here is when the character is launched, the capsule won't launch with it. And so you can have a scenario where the ragdoll's on the ground, falling on the ground like a few feet away from where the capsule was, and the capsule will still be at its initial location. And so if you walk through it, it will like start blocking your camera. So what this will do, this will just remove the capsule from the map essentially. Because when you remove the collision, it'll just fall through the map. But the mesh will stay on the ground because it's simulating physics. And when you're simulating, it won't move through the ground when he's simulating physics. So we want to get our static mesh, and we want to check if that's valid, because if it's been destroyed already, we're not going to destroy it again, right? And then we're going to plug both the false branch into that, and then also the set collision enabled into that, and then connect that to the enumeration. The switch on the enumeration. All right, so let's get our dummy into the ground. And so you see he's going in the direction that the block is being thrown at. Okay, so I forgot to add this. On our TK objects, we want to click that eyelash and make sure that's instance editable, and we want to get that and then plug that into the selection. Okay, and then we can go inside of our map, our level, and we can click on the object. So if you have a torus there, you can, under default where it says TK objects, you can switch that to torus. And so now that'll be a torus, and those are already blocks by default. Okay. All right, so we're getting towards the end here, baby. All right, so at the very end, let's add a sound, just like a crumbling sound. You can find some free sounds on freesound.com or freesound.org, whatever it is, and search for CCO sounds, Creative Commons license 0, and you can use those for free. Just try to credit the people that you use. I can't think of the person that I took this from. I will put their name in the link though. Okay, so now inside of our master field, I want to destroy it. I want to destroy this master field after it's already crumbled the object. So at the end where it has activation type, where it goes delay, we want to copy the destroy actor and paste that on the delay branch as well. Okay, and again, you want to probably duplicate this master field and then move it into your own content browser rather than making changes to your base master field. Okay, I just do that because I don't afraid of anything. All right, so now let's create a wall that can break. So you can just drag a block into the map and then you can size it the way you'd like, and then you can drag it up, hit end to snap to the ground, and then go to fracture mode, click new for creating a new geometry collection. We can name it GC_wall and then put it in the folder that you want it to go in and create it. And then we want to make sure all is selected, so select all just in case, and then fracture it. And then click fracture. Now fracture it. All right. So save. And selection. If we have our wall selected, we can search for bone. Actually, we're going to deal with the damage threshold real quick. And I actually do this wrong. The reason it starts at the higher and gets lower is because when you have clusters, well, this wall only has one level, so you don't need this many damage thresholds on it really. But if you had multiple fracture levels where you say you fractured it and then you click down on one of those bones that you fractured and you hit fracture again, it's going to create a whole nother list of fractures. And the reason you want it to go from high to low rather than what I did, low to high, is because if you start low to high and you fracture at, everything's going to fracture because you have your root level, which is fractured, and then you have the bones that are fractured below that, but they're all attached to that main root thing. So when the root thing falls, everything will fall along with it. But when you have it high to low, those lower, the children of your root fracture, those children fractures, when the damage threshold is lower than the root damage threshold, those things will start to crumble first. So like if it's at 50,000 for the root and 500 for the child, those childs, when they hit that damage threshold, they'll start falling before that 50,000 is hit, if that makes sense. Okay, but once you got that, all right, let's test that out. Okay, so that's crumbling. If you want to remove that colored bones, just on the wall, search for bone. And then show bone colors, click the false. And test it again, why not? You've already spent an hour here, what's another 30 seconds? Okay. All right, so now let's search for anchor. This is also in here by default. This is the anchor field. I hit G hitting G will remove things on your map that you don't want to look at, like the widgets and things like that. You can hit G to remove that. So that's why that was hidden for a second. So I'm going to scale that. I'm going to put one anchor at the bottom of the wall and one anchor at the top of the wall. So pretend this top was connected to a ceiling. All right, and then inside of our GC wall, where it has initialization fields, we want to add 2 array elements and then choose these fields that we just added to the wall. And I'm going to resize this wall just a little bit more. And again, pretend this was attached to a ceiling, and then you can kind of see why I did it like this, where you would throw it, and then it's like just the center kind of crumbles or whatever. All right, so that's why you would do that. So now let's create a center dot that helps you see what you're currently highlighting. All right, so right click, create widget, user interface, user widget, and then open it up. I'm going to use an overlay. An overlay is basically the overlay of a screen, so wherever you put the thing in here will be there on your screen. So I'm going to use an image. I'm going to center it. So the way the overlay works, if it's in the center, it's going to be in the center of your screen. I'm going to change to draw type to draw as rounded box. And I'm going to go down to render transform and click on that arrow and then scale it to like 0.5, which is actually still a little bit too big. Anyways, compile and save. Now let's go back into our sandbox character. And on the aim input, when it started, we will create a widget. And will be the center dot widget we just created. And then from the return value, we will add to viewport. And then from the return value, let's quickly remove from parent. And then we will connect that to our canceled or our completed execution pin, which completed is when you remove, you're no longer pressing it. Okay. So this helps with knowing where you're looking when you're highlighting. It is off a little bit as far as aiming when you're actually throwing it. So yeah, as you can tell, like it's not necessarily going to where the dot is, or it's throwing in that direction, but it's mainly for the highlighting. Okay, before I leave you, I want to clear up a couple things real quick if you want to fix a couple issues that I thought of. If you don't want it to be able to just go through a wall like that, where we're doing the interpolation or the VRInterp2, click sweep to be true. That is a very shoddy wall. All right. And then if, for example, you grab something and you have it stuck in a wall now and you move far away from it, if you want it to not be selectable at that point when you get a certain distance away, let's go to our trace for TK object, and if we're grabbing an object off the false, let's get a validated get of our TK object, and let's get the distance to, and we will get the distance to ourself. So let's search for self. Okay, and then plug those into the corresponding nodes. And then from the TK, we want to get owner and then plug that in to the distance node. And then we want to check if that's greater than our trace distance. So if it's greater than our trace distance, let's just go ahead and drop it. All right, so to do that, we will just, from the return value, get a branch, and then we will just call our release object function, and then we will also clear our timer because we don't want it to interpolate back to our hand. And then we want to make sure we click that it's no longer grabbed. Okay. And then we'll see, we get far enough away, he'll let go. Open up his hand, and then we can pick it up again. And I missed. Okay, so last thing, to prevent sliding when playing that montage, we got to go into that montage, and we need to go to Window and open up the Anim Slot Manager and add slot, and we can call it something like upper body. And then on the left where it says default group, select that drop down and slot name, choose upper body. And then we need to go into the animation blueprint And off the default slot, we need to cache that. So new save cache pose, we can call it default cache. And then we need to call that cache. So search for default cache. And choose that. And then from that, we need to search for a default slot. And then we need to click on that slot and change the slot name to upper body. And then we need to cache this. So we can drag off of that and cache new save cache pose, call it upper body cache. And then now we need to call both of these caches and attach them to this layer, to a layered blend per bone node. So you can copy that layer blend per bone node or search for your own and create a new one. And then call these caches the default and the upper body. The default will go into the base and the upper body cache will go into the base 0. All right, move this over a little bit. And then attach the default cache to the base pose and upper body cache to the base pose 0. And then connect that to the off root bone slot. And then we need to add, we change this clavicle to thigh underscore L and change the blend depth to -1. That will filter out the thigh and anything below it so the legs will move. And so we need to do one for the left thigh too, thigh underscore L, -1. And then we need to add the pelvis, so anything above the pelvis will play the animation from the default montage that or the upper slot montage that we created. Okay, so there you go. All right, well, there you go. Thanks for stopping by. I hope you learned something. I had fun making this, so I hope you have fun making it as well. Thanks again for coming by and checking out my channel. It really helps motivate me and keep me on my Unreal journey. So thank you. Take care.